All right, so this is the last batch for Chapter 1 for Chem 1. So we have two videos. The first one deals with types of elements. Now, a lot of this will sound familiar to you, maybe some new concepts here, but we're going to try and show examples to help you follow through on the various properties of these elements. So we're going to use the periodic table, so you want to get the periodic table and take a look at it. Excuse me. We're going to deal with the four types of elements, and they are metals, nonmetals, metalloids, and noble gases. Now, we're going to be able to figure out what element is which of these four types based upon the placement in the periodic table. So if you have your paper sheet, and I picked the paper sheet because you can draw on it as opposed to getting it online. But the paper sheet that you have, which looks like this, there's a line right here: boron, aluminum, aluminum silicon, silicon germanium, germanium arsenic, arsenic antimony, antimony tellurium, tellurium polonium, and then polonium acetate. You might want to darken that line in so that it becomes obvious where the demarcation is between metals and nonmetals, because that's what we're going to be looking at. Don't have to, but it helps kind of make it jump out. So if you want to pause and do that before I move on, that's fine. So we get that line put in there, and the elements that lie to the left of that line, the elements that lie, here's your line right here, and everything that lies to the left, including these two down here, are considered metals. So the vast majority of elements on the periodic table are indeed metals. So well over 3/4 is metal. Everything to the right is considered nonmetals. Okay? And then if all elements right on the line, with the exception of aluminum, is considered a metalloid. Now, aluminum is a metal, and we know that because we have cans made of aluminum, we have car engines and airplane engines made with alloys of aluminum. So aluminum is definitely a thing as far as metal is concerned, but everything else is considered a metalloid. So what we need to do in order to identify not only the placement on the periodic table, but if we can actually look at one of these elements, we can tell by kind of looking at it and kind of examining how it reacts, the physical and chemical properties of these elements. So let's take a look at gold. Now, you can see in this picture here, we have gold in all kinds of shapes and contraptions. It looks like these are like really good like plugs and some kind of shells that we use to in electrical work. It turns out gold is really good at conducting electricity, and that turns out to be one of the physical properties of metals in general. But if you have a house made out of gold wiring instead of copper wiring, like most houses do, well, you probably have a really good, efficient electrical system. Just don't tell anybody in the neighborhood that, oh, by the way, I've got gold electricity in my house. You may not have it much longer. Anywho, so we look at the physical properties of these elements. We can describe the chemical and physical properties by making an examination of the picture and what we know about gold in general. Okay, the first thing I notice is that gold has luster. I mean, this is spectacularly beautiful. The colors just jump out at you. In scientific terms, that's called luster. Now, like if you were to get a car and you get a color that resembles a shade like this, they'll call it metallic gold or metallic blue or metallic green, where it looks like it's got luster. But we use the word luster for a physical property for what we see with all metals. Metals all look like, even mercury. Mercury is a liquid metal, but if we actually take a look at mercury, it's a shiny, silvery, lustrous color. So even the liquid fits that description. Now, these two right here, malleable and ductile. Malleable and ductile, malleable means you can shape it into, or bend it into shapes, and ductile means that you can stretch it into wires. It's kind of like bending as well. You do all kinds of flexible things with it. Some metals more than other, but they're all malleable and all ductile, which is why we have gold shapes here. It's really easy to do, particularly if you melt it down a bit and you or get it heated up. It'll bend very, very easily. We can, like I said, we use gold wiring for electricity in some laboratory setups, just to eliminate as much resistance as possible under normal room temperature conditions. So malleable means bendable or shapeable. Ductile means it can be stretched into wire. And only metals can do that. The next physical property, and we talked about that as well, is that it conducts electricity and it conducts heat. Take, for example, a frying pan. A frying pan, an iron skillet. My wife is a great cook, and she loves using her iron skillet. Well, the iron skillet is, as advertised, made of pure iron. So, if you put that on the stove top and crank up the heat, that skillet gets hot real fast. Why? Because the iron passes on the heat from the flame to the surface of the iron, and that allows the food to cook the way it does. And the last one, and this is a chemical property, and we're going to talk about this in greater detail later on. It becomes really important when we start talking about ionic compounds towards the end of the semester. But it forms positive ions. Anything to the left of the staircase is a metal, and all metals form positive ions, and that becomes, really, like I said, really important later on. And I do want you to know that now. So 5 properties. Lustrous is malleable, is ductile, conducts heat and electricity, and it forms positive ions. Now, the next one we're going to talk about are nonmetals. So in this case here, we take a look at a solid. Now, if you take a look at the periodic chart, sulfur is over to the right, but look, it's chunky. It's a solid. However, you go over a little bit more to chlorine, and oh, that's not it. There's the chlorine. There's chlorine gas, kind of a mustard-looking gas. In fact, in World War I, they used chlorine as mustard gas. Right? The shininess is because of the beaker. It's not because of the color of the chlorine. It's kind of a dull green-yellow color. And the sulfur, while, again, the lining kind of makes it look like it's somewhat lustrous. In fact, if you take a look at the powder here, it's not really very lustrous at all. It's kind of a dull yellow color. Okay? So, if you take a look at the periodic chart, the metals and the nonmetals are separated by this line. And when you have opposite sides of a chart, they tend to have opposite properties. And so like the color is one. Instead of a flashy, spectacular color like the metals have, you kind of have this dullish looking colors for the nonmetals. How would you compare the ability to be shaped and stretched? Well, take another look at that, and what? It's chunks. In fact, if you look real close, you see that it's kind of a powdery form of sulfur around there. So this is very brittle. If I were to take this and throw it against the wall, it would shatter into 1,000 pieces. If I take a gold and throw it against the wall, not only will it not shatter, but people are going to kill each other just to try to get that piece of gold that I let loose. So that's not going to happen. Anyway. So the ability to be shaped and stretched like metals is non-existent. We can't do that. How would you compare the conductibility? Well, to be conducting heat and electricity for the metals, it's going to do just the opposite. It's going to hold the heat. We make insulators out of non-metals. Porcelain, which has some silicon but also has sulfur in it and some other elements in it that are non-metals, carbon, will actually hold the heat. So if we have some kind of insulator, we guarantee there's going to be some of the non-metals involved in that, but absolutely no metals, because the metals will pass on the heat, not pass it, not hold it. And keeping these comparisons in mind, how they're opposite each other, what conclusion can we make about the charge of the ions that we'd expect out of non-metals? Well, because non-metals are opposite metals. Metals form positive charges, non-metals can form negative charges. So, properties of non-metals: dull color, brittle, good insulator, and forms negative ions. Okay, now we get to the third group, which is the metalloids. Those are the elements right on the staircase that you darken in, hopefully. And the metalloids are between the metals and the metalloids. Let's take a look at some silicon. Silicon is right here. Now, silicon is rather interesting looking. It looks like a bunch of rocks that have some luster to it. In fact, we find that non-metals are lustrous like they were metals, but if you were to throw it against the wall, it would crumble. So it is metallic-like in color. It is non-metallic-like in being brittle. It turns out that it forms negative ions, like it was a non-metal. But here's the thing that makes metalloids so important. And it's this concept of semiconductors. Now, if it wasn't for semiconductors, we would not be able to have computers or iPhones or anything that holds large amounts of memory, RAM, if you will, because semiconductor means it both holds heat or electricity or passes on electricity. So that's perfect for computers, because computers can store electrical energy in the form of some kind of binary code system that we have. Then when we type in something where we want to relay the information out from the memory of the computer onto the framework of our monitor there, then it's going to pass on the electric charge, and it's going to be translated into some image on that monitor. So it holds both. It both holds the charge and passes on the charge and makes that semiconductor. The two elements that are the best at that are silicon, as in silicon chips, and the one that doesn't get as much publicity but should, because it's just as plentifully used, that is germanium. Germanium and silicon are used in computers a great deal. So there's a lot of mining going on trying to get both of those elements. Finally, the last type of element is the noble gases. We will discuss this later. So your practice problems is I want you to take a look at the periodic chart, find these 5 elements, and tell me if you're dealing with a metal, a non-metal, or metalloid. Good luck.